We're basically going to, and it's going to, the first section is fairly easy. It's not that bad, the first section. What gets students is those logarithms. But as long as you can remember those properties of logarithms, you're okay. It's just that you have to remember those properties of logarithms. But the logarithms get students, and that's going to be the second section. So the first one is not difficult. It's fairly easy. This is section 4.1. And this is going to be exponential functions. It's an easy section. It's not a difficult one. All right. First of all, an exponential function looks like this. Here's an example of an exponential function. F of x equals 3 to the x. Versus something you had before, f of x equals x cubed. So here, what was the exponent? 3. Your base was what? X. Okay? Here, what is your exponent? X, your base is 3. So whenever the variable is located in the exponent, this is called exponential. So an exponential function is where the variable is located where? In the exponent. Okay, so that's called an exponential function. The variable is located in the exponent. All right? Now, you're going to graph this eventually, but it's easy to graph. You're just going to plot some points. Use the t-table. That's how you're going to do it. It's easy to do. But you got to be able to use your calculator also. Okay? So, here's what I want you to do in your calculator. Okay, let's find round to 2 decimal places. Let's suppose you want to find 2 to the 1.3 power. 2 to the 1.3. All right, so on your calculator, you're going to do this. Now, if you have this kind of calculator, this is an easier calculator to use. If you use a different calculator than what this is, the order in which you put things may vary. But this kind, whatever you see is what you write, what you type in. So I need to first do the base. What's the base? 2. So I say 2 raised to the, all right, see this right here? This right here? Okay, click on that. So that's your power function, and then you raise it to what power? 1.3. So you can just say 1.3, just like this, and then press enter. And so it's about 2.46. Okay? So it's about 2.46. Now, the reason this is going to be important because when we do natural logarithms or the natural base, there's something called the natural base. That's going to be the number e. And we're going to talk about e next class period. All right, number 2, suppose you had this. 3 to the square root of 4. Oh, let's not do 4. 5. And the reason I didn't do square root of 4 because that's 2, right? And then 3 squared will be 9. So you didn't use your calculator for that one. Now you're going to use your calculator, the square root of 5. All right, so here's how you do this. You're going to say 3. You're going to raise it to the square root. So you got to press the square root button. Oops, wrong one. Square root button. Looks like this, right? It puts a parentheses in there. What goes inside the parentheses? 5. Close parentheses. Press equal. And you get 11.66. Okay? 11.66. All right, 3. 1/3 raised, notice I put 1/3 in parentheses, 1/3 raised to the square root of 7. All right, now see how the base is a fraction? You see it, right? You got to put that in parentheses. So you're going to put parentheses. Then I say 1 divided by 3. That's 1/3, right? What do I then do? What do I press next? Close parentheses. What do I press next? Raise it. And then square root, right? Square root of 7. So second x squared, you get that. What do I put inside that parentheses? 7. Close it. Press equal. And that's 0.05. Okay, so any questions at this point? Okay, now the base of an exponential. We're going to talk about this. I think you picked up a handout on exponentials, did you? Okay, so on that first page or second page, it tells you that the base must be a positive number. So let me write this down. So the exponential has this form, exponential function. Okay, an exponential function has this form. F of x is going to equal b to the x power. So f of x equals some base raised to the x power, and that's exponential because where's the variable located? In the exponent. Okay? The base, b, the base must be a positive number. The base cannot be negative. The base has to be a positive number, but the base cannot equal 1. So it can be any positive number but what? 1. Cannot be 1. Now, when we graph this, we're going to come back and we can discuss why it must be a 1. Yeah, I'm sorry, why it cannot be a 1. All right, but you got to look at the graph of the exponential in order to understand that. All right, but for right now, just remember it's got to be positive, any positive number, but it cannot be 1. All right. And so if I want to graph, and we're just doing a simple one right now, and then you should be okay with that simple one. So let's suppose I want to graph this. Okay, listen carefully. Graph f of x equal 2 to the x. Graph f of x equal 2 to the x. Use a t-table to help you. If x is 0, and use your calculator if you need to. If x is 0, I get y equals 2 to what power? Okay, do you remember what 2 to 0 power is? Nope. 1. Remember, any number raised to 0 power is 1. If you didn't remember that, use your calculator. 2 raised to the 0 power, 2 raised to the 0 power equal 1. Okay, so any non-zero number raised to the 0 power is 1. You learned that last semester when you dealt with the rules of exponents. If x is 1, y equals 2 to the first, which is what? 2. Use some negative numbers for x also. Now remember, we said the base can be negative, but can the exponent be negative? Yes. So you raise when you raise 2 to the negative 1 power, use your calculator on that one. Now you learned about negative exponents last semester. I'm sorry, in 98. That's where you learned about negative exponents. You don't remember that? You make a negative exponent positive by bringing it down to the denominator, so that's 1/2. All right. It's been a while since y'all had this, I guess. But you don't have to remember those rules, really. You can just use your calculator. So it's 2 to the negative 1 power. 0.5 is 1/2, right? 0.5. When x is 2, I get y equals 2 squared, which is 4. When x is negative 2, I get y equals 2 to the negative second power, which is, so here's the idea. If 2 squared is 4, then what's 2 to the negative second power, real quick? What fraction? 1/4, which is 0.25, right? So if you use your calculator, 2 to the negative second power is 0.25. It's kind of like this. If 2 to the first power is 2, then what's 2 to the negative 1/2? 1/2, which is 0.5. Okay, you'll learn about those rules were in 2 semesters ago. All right, but you don't have to remember them and actually do this because you have access to a calculator. Now I want to show you what's happening so far. What's happening so far, and I need you to get the general idea of what an exponential looks like. So here's what's happening so far. So on your graph paper, we're going to plot these points, and we may need to plot a few more. But you're going to get 0, 1, which is here. Agree? You're going to get 1, 2, which is here. You're going to get negative 1.5, which is here. Make sure you see this. You're going to get 2, 4, which is here. You're going to get negative 2.25, which is here. Okay, look. I'm going to go ahead. Oops. See what's happening? So if x is 3, I want you to think about this. Just look at the positive numbers right now. If x is 3, what's 2 cubed? 8. Y'all see that? Yes or no? So you see how, remember the idea of exponentials is like I say, rabbits multiply exponentially. So notice it increases very rapidly. See that? Increases very rapidly. And then over here, I want you to look at what's happening. Over here, my y values are getting what? Smaller and smaller. Now, before I go any further, I'm going to ask you this. Is my y value for this function right here, is any of these y values ever going to be negative? I want you to think about that. No. Never going to be negative because my base is what kind of number? No, it's positive though, right? And a positive number raised to any power is always what kind of number? Positive. So when I make my exponents negative, this graph is getting closer and closer to which axis? The x-axis, but it will never cross it. All right? Now, before I go any further with the word I'm about to use, make sure you understand what I just did. So as I go to the right in terms of positive numbers in my domain, my y values are increasing exponentially. See that? Getting bigger quick. Over here, when I go to the left, my y values are getting smaller and smaller and smaller, but they will never become negative. So will there be an x-intercept? No. Okay? So it's just getting closer and closer to the x-axis. Okay, you understand the graph? So when you study this section, remember exponential functions, part of it is going to be rising rapidly or falling rapidly, and the other is getting closer and closer to what's called a horizontal asymptote. A-S-Y-M-P-T-O-T-E. A horizontal asymptote. So we're going to talk about horizontal asymptotes next class period. So all exponential functions have a horizontal asymptote. And it's easy to find. But for right now, I need you to understand what 2 to the x looks like. And you see how I found it. First of all, I plotted some points. See those points? Round 1. See these points? Was that difficult to find? Yes or no? No. Okay, then we plotted those points. We noticed that we plot those points, this part of the graph increases rapidly. this part of the graph you have to think about a little bit more. These y values are getting smaller and smaller and smaller. They're never going to be negative because a positive number raised to any number is always going to be positive. It's always going to be positive. And it's never going to be 0. So it's never going to cross the x-axis. All right, so you draw an arrow like this and draw an arrow on the top. Now, see where the graph kind of looks like it's becoming horizontal? See how it looks like a straight line? Although it's not because it's getting smaller and smaller, right? But you see how it looks like it's a horizontal segment right here? It's not, though. That axis right here, what's this axis called? The x-axis. That axis is your horizontal asymptote. Okay, so for this right here, the x-axis is the horizontal asymptote. The x-axis is the horizontal asymptote. Now, for every exponential function, is the x-axis always going to be it? No. Because remember we talked about shifting up and down? So I could move this x-axis down, or I could move it what? Up. No, because if I had this, and we'll do this next time, but let's suppose next time I want to graph this to the x minus 3. So that says I take 2 to the x and do what to it? Move it down. So 2 to the x, what was the horizontal asymptote? The x-axis. Now I'm shifting it down what? 3 units. So you see where you get a different horizontal asymptote? It will be negative 3. But I think what she's asking is, remember with a quadratic function we had an axis of symmetry, and we named it. We name a vertical line using what letter? X equal. We use a horizontal line using what letter? Y equal. So my horizontal asymptote will be y equals what? Negative 3. That will be your horizontal asymptote. So we're going to do more with that next class period, but you did ask a question. You wanted to know what would it equal. It is negative 3, but you don't just say negative 3 because it's what kind of line? Horizontal. And how you name a horizontal line? Y equal. Okay? So that's why you spend some time talking about graphing vertical lines. You talked about graphing horizontal lines because you are going to need that when you start talking about asymptotes and axis symmetries and all that. So everything builds upon each other. So the last 2 courses you took build upon this. That's why I always told you 98. Make sure you remember what we for 99, what you did in 98 for college algebra, what you did in the last 2 courses. Everything builds upon each other. All right. So next class period, starting at 8 o'clock, we're going to do some more with graphing these. It's not hard. Most students can handle exponential functions. Now, most students, I mean like 99%. I'm not going to say 100 because it's never 100. I'd like it to be, but it's never the case. All right. Okay, so let me go ahead and turn this off.